Welcome to Lesson 6.2, Operations with Polynomials for Algebra 2 Trig. Let's start with what a polynomial is, because otherwise we can't know much about it. Polynomial is defined as an expression where variables can only have natural numbers as exponents. Again, natural numbers mean like 1, 2, 3, 4, so no negatives, no zeros, no roots, nothing weird. The degree of the polynomial is the sum of the exponents of the largest term. Okay. For each example, let's determine whether each expression is a polynomial. If it is a polynomial, we'll state the degree. Obviously, if it's not a polynomial, we can't find the degree. It's not possible. So let's think about it. So I'm going to look at each of my variables. So in this first one, I see the variables are x and y, but the problem is I notice there's one in the bottom. Remember, anything in the bottom means it has a negative exponent. And if it has a negative exponent, that means it's not a natural number. Therefore, this one is not a polynomial. Dun, dun, dun. For the second one, if I look at each of the terms, all the variables are not in the denominator. They all have natural numbers, like 5 and 1, 4 and 2, 1 and 1. So now I need to separate each term to see what the power is of each term. Terms are separated by pluses and minuses. So if I look at this first term, I would add 5 plus 1 to find its power is 6. To look at the second term, I would add the exponents again, 4 plus 2. So again, I get a sum of 6. For the last one, it would be 1 plus 1, or 2. So again, the degree of a polynomial is the sum of the exponents of the largest term. The largest sum we see is 6. So this is a 6th degree polynomial. The next thing asks me to simplify each expression. This is nice, it's just collecting like terms. So let's make sure we can do that correctly. Here I have 2a cubed minus a cubed. That's going to give me a single a cubed. Then I have positive 5a subtracting negative 3a. Be careful of that double negative. 5 minus negative 3, positive 8. Negative 7 and positive 2, negative 7 minus 2. So that would be negative 9. So the result of this difference would be a cubed plus 8a minus 9. For the next one, notice that these parentheses, there's one here, but this one's separated. So really it's just asking me to distribute that negative y. Be careful about negative signs. It's really easy to make a mistake. So if I do negative y times 4y squared, I would get negative 4y cubed. Negative y times 2y would be negative 2y squared. Negative y times negative 3 would be positive 3y. So the product would be negative 3y cubed minus 2y squared plus 3y. Nothing too outrageous there, should be pretty easy. The last one that's kind of fun here is a cube rule. So I'm a little lazy. I don't know, it's like multiplying out a plus b times a plus b times a plus b. So if I have a shortcut in my head, I can use it. Here's what I mean. That this is equal to, and I just have this memorized after doing it for a while. There are some patterns to it, and I'll explain in a second. So I have a to the third plus 3a squared b plus 3ab squared plus b cubed. The way I remember it is it starts with a third power because it's a 3. It ends with a third power. Notice the a's go a to the third, then a squared, then 1a, then no a's, they go away. The b's do the opposite. There's no b's, then 1b, then 2b's, then 3b's. And then the coefficients here are 3 and 3, again reflecting that 3 there. So if I can remember that, again, I don't have to multiply it out. If you forget it on the test, just multiply out FOIL the polynomial 3 times. So let's see if we can figure this out. In this example here, a would be 4y, and b would be negative 1. So if I replace each of those with what I have here, I'd have 4y cubed plus 3 times 4y squared times negative 1 plus 3 times 4y times negative 1 squared plus negative 1 cubed. Let's make sure we don't forget to distribute that exponent to each part. So I have to do 4 to the third as well as y to the third. So let's see, 4 to the third, 4 to the third, oh yeah, that's, I believe, 64. Here I have to do exponents first, so 4 squared is 16 times 3 is 48. Oh, but Ms. Rogat forgot something because there was a -1 there. Oh, don't forget your negatives. Please fix that. In the back here, again, doing my exponents first, -1 squared would make it positive, so I just have to do 4 times 3, which would be 12y. Lastly, -1 cubed would just be -1. So this would be the expansion of 4y minus 1 quantity cubed. Again, if you forget it, you can always multiply it out 3 times. I think that's a little faster. So I hope you kind of get 6-2 now, and if you need to watch this again, watch it again. Have a great day.